Okay, 14, clearly an alternating series. I'm going to use what's called the alternating series test on it, Liebens test. And the first thing I do is I just want to write down what AN is. It's definitely an alternating series, though. I get n to the 6n, and then I get 6n plus 1 factorial. And what do I want to show? I want to show that there's a relationship between the terms. And that relationship is it's decreasing. So something like this over here. So let's write it down and see if that's true. So you get n, 6n, 6n plus 1 factorial. This would be n plus 1 to the 6n plus 6. Well, it looks nightmarish. What do you get on bottom? We get 6n plus 6 plus 1, which is 6n plus 7 factorial. Let me see if I said that right. N plus 1, that's 6n plus 6. Yeah, I did okay. So the first thing I do is just kind of work on that inequality. And to do it, let me just, I made the factorials on one side. So it's certainly easy to do. It may not be easy to figure out, but I'll do that. And then I'll put this, n plus 1, 6n plus 6, and then you get n to the 6n. All right, let's take a look, see what we can do with that. Let's see if that's true. And kind of looking at the top, I'm going to say, a lot of these things cancel off, and I'll just write this down. You get 6n plus 7, 6n plus 6, 6n plus 5, 6n plus 4, 6n plus 3, 6n plus 2, and then you'd have 6n plus 1 factorial. That would just cancel off. All right? Now I'm going to look at the next thing, and the next thing I'm looking at is, I'll try to concentrate on some things over here, and I'll concentrate on the n plus 1 over n to the 6n, and then what do you get over there? You get something else, wouldn't you? You get n plus 1 to the 6th power. Let me see if I did that right. Yeah, I think I did okay. All right. Let's look at that. Try to make some sense out of that. Let me see. 1, 2, 3, 4, 5, 6 factors, 6 factors. Let's write that down. And what do you get there? Well, it's going to be 6n plus 7 over n plus 1, 6n plus 6 over n plus 1, 6n plus 5 over n plus 1, 6n plus 4 over n plus 1, 6n plus 3 over n plus 1, and 6n plus 2 over n plus 1. And when you get over here, let's write this down. 1 plus 1 over n. Right, that's not so bad. And then it's going to be to the nth power. And that whole thing's being raised to the 6th power. All right? So I want to point out, as n gets really large, that number there is going to be asymptotic with e to the 6th power. It'll never exceed it, by the way. So this thing over here is not going to exceed e to the 6th power. Let's look over here and see what happens over here, though, and see what we get. All right? And looking at it, just kind of looking through it, and just, one term at a time, so to speak. And I'm going to divide through by n on each of these guys now. And what do you get? You get 6 plus 7 over n. And at the bottom, you get 1 plus 1 over n. Here you'd get, and again, divided by n, you get 6 plus 1 over n. Actually, you know what I could do? We could reduce that, but let me just keep going with it. And you get 1 plus 1 over n. What do you get there? 6 plus 5 over n. And then you get 1 plus 1 over n. What do you get here? 6 plus 4 over n. 1 plus 1 over n. And what do you get there? You get 6 plus 3 over n. 1 plus 1 over n. What do you get there? 6 plus 2 over n. And what do you get there? 1 plus 1 over n. Well, I hope you realize, again, as n goes towards infinity, that this thing over here, well, a lot of things disappear and you just get 6, 6, 6, 6, 6, 6. How many you get? 1, 2, 3, 4, 5, 6. So as n goes to phase, this really looks like 6 to the 6. And the other side really looks like e to the 6. I hope you realize that this is clearly bigger than this. So I got that part covered. All right. It took me some time, but I got through it. All right. The other thing I want to point out to you is that I got that the limit as n goes to infinity on it. Kind of did that already, though, didn't we? But anyway, let's write it down. All right. So we did this part here. Let me point out what we did. We got this part covered. Now we're doing a limit over here. And the way I did that, kind of write it down. I'll point out what I'm doing over here. I'm just writing down what the terms look like. And I realize it's tough, though. There's no doubt about it. But you're going to get, a lot of n's on top. They're all n's, by the way. But there's 6 times n factors of those things. How many things you got in the bottom? Well, it goes, like 1, 2, 3, all the way up to 6n plus 1. And that's also going to be 6n terms. It's upper minus lower plus 1. And so this over here, there is some finite number here. I know that because of the n. It's this part I'm interested in. And what's happening over here? Well, that bottom, right, is getting larger than the top. All right? So what am I going to say over here? That this thing, as n goes to infinity, it's going to go towards 0. And we're done by the Leibniz. All right, let me see what they wrote down. I say the n is decreasing sequence converges to 0. The original series converges Leibniz test, which I call the alternating series test. I know it's getting more difficult. Yeah, it's getting more difficult. I suggest you investigate using a computer algebra system, Mathematica or Sage. And I'll probably post a video for that one as well. Thank you.